Welcome back, everybody, to the final segment of Restoring the West. Next up, we have Dr. Paul Miller. He currently works for the Colorado Basin River Forecast Center as the Service Coordination Hydrologist in Salt Lake City. He also has 7 years of experience working for the U.S. Bureau of Reclamation in the Lower Colorado region, investigating the impacts of climate change to the Colorado River Basin. He received his Bachelor of Science in Environmental Hydrology and Water Resources from the University of Arizona in 2003, his Master's of Science in Environmental Engineering from the University of Notre Dame in 2005, and his PhD in Civil and Environmental Engineering from the University of Nevada, Las Vegas in 2010. And today he will be speaking to us about decision support in the Cadillac Desert, climate change, and water supply in the water-stressed and politically charged western U.S. Welcome.
Cool, thanks Erica, and thanks everybody for allowing us to be here. I work for the Colorado Basin River Forecast Center, as Erica said, and this title I have, the Service Coordination Hydrologist, is just a fancy way of saying that my job is to be out there and to try and understand the needs of our stakeholders within the Colorado River Basin and try and figure out the best way for my office to help you. So if you think I'm talking to you, I am. It's really, we want to understand your needs and we want to understand what we can do to help you as far as the water supply situation goes in the Colorado River Basin and in the eastern half of the Great Basin as well. So who are we? We're actually an office within NOAA. We're part of the National Weather Service, but I know, speaking for myself, I don't know that much about the weather. I'm not much of a meteorologist. I'm very much a hydrologist, and even though we have meteorologists in our office, we're very water focused, and we work very closely with the weather forecast offices. We're an operational office, and we're located just about an hour and a half away in Salt Lake City, but we're really highly collaborative. We don't do a lot of independent research. We don't kickstart a lot of our own projects, I guess, for lack of a better term. We really rely on feedback from our stakeholders to understand what you all need, because we're really all about decision support. So, like I said, we work with a really broad set of stakeholders. Our top two stakeholders are probably the weather forecast offices and the Bureau of Reclamation. So when you're dead asleep, 2 o'clock in the morning, you've got a big test the next day, and your phone starts buzzing because there's a flash flood like 80 miles away, that's the weather forecast office's fault, but we helped. So, so just letting you know that that's the kind of stuff that we're involved in with them. We also talk with a lot of municipal and agricultural users. We just had the Southern Nevada Water Authority in our office yesterday, talking with them about how we can help them better plan for their water resource needs, because they're highly dependent not only on the water that's very close by at Lake Mead, but also on the water that's up in Lake Powell, upstream in Lake Powell, and even all the way up into southern Wyoming. We rely so much on the USGS and the Natural Resources Conservation Service, and a lot of our other sister federal agencies. I'll talk a little bit more about it, but data is really at the heart of what we do. Without data, our products really aren't worth a whole lot. But we work with a lot of state agencies, academics, NGOs. We've even started to really try to work more closely with tribes. We get some data from the Huachuca tribes in southern Arizona, but we could really do a lot more with them. So anything we can do to try and work more closely with Native American partners, we've really been trying to do this. But yeah, we receive data from a lot of these people. So just a little schematic about how we all fit into things. River Forecast Centers, like I said earlier, there's 13 of us, but we're all different. The ones in the west really tend to focus a lot more on water supply. As you might imagine, those in the south, near the Gulf Coast, are more focused on flooding, all that stuff that was going on about a month ago in the south. There was a lot of work being done at the River Forecast Centers, looking at those flood flows, trying to predict when they're going to recede, trying to predict how high they're going to get. In terms of water supply forecasts, our office has actually kind of led the way as far as innovating new methods, testing out new techniques. So we're really focused on water supply because that's what our stakeholders really want to hear from us. So, I really encourage everybody to go to our website. It's CB, as in Colorado Basin River Forecast Center, CBRFC. .noaa.gov. If you have gone to our website over the past year and you're like, oh, this is a clunky mess, it was, but we've done a lot of improvements on it over the past year, and I think it's really slick now, and it's only going to get better. So some of you might be saying, well, what's the big deal about water supply forecasting? You just told me you don't know anything about the weather, so I can just say, well, if there's about 100% snowpack in the upper basin, about 100% stream flow. It's not quite that simple. We rely a lot on precipitation measurements and snowpack measurements, but what I'm showing here, and I think Gigi just showed a similar version of this plot just a little bit further upstream, but this is the unregulated flow at Lake Powell over the April through July period. And you can see there's just stuff. I mean, it's so variable in our basin. It's really hard to predict average and then get average. But this kind of faded purple line that's probably a little hard to see is the percent of normal of this upper Colorado Basin River snowpack. And you can see we've had some really good years that didn't translate into particularly wet years. We've definitely been close to average snowpack-wise, but well below average stream flow-wise. We've also had some not so great years. We're just barely below average, a little bit above, but still there. So while snowpack is very important, we look a lot at modeled soil moisture data. We look a lot at the temperatures. We're starting to look at dust on snow impacts, and I'll talk a little bit more about that later. So again, we're all about providing decision support, and it all starts with data. We're kind of unique as an agency in that we don't control any of our data. We don't have our own data monitoring networks for the most part. This is a USGS stream gauge and a NRCS SNOTEL station. These stations and a whole bunch of other stations really form the basis for what we're doing every day at the River Forecast Center. So we take all that data, we bring in radar information, we do a lot of quality assurance and quality control on the data, because as soon as bad data slips into our methodology, we start seeing weird things going on with our stream flow forecast. So we really try and make sure that we're getting good data in, that we're getting consistent quality data in at frequent intervals. We're checking the data at least 3 times a day, and that's 7 days a week, 365 days a year. So we feed all that into our hydrologic model. That's just a fancy schematic looking at that, but we can talk in more detail about that. And then our model spits out a stream flow forecast, and we compare it to the observations. So you'll see these red dotted lines. Those are USGS observations, and you can see our model, we were a little bit off there, but for the most part we're doing pretty good. This is the Animas River at Durango, but we're not doing too bad, which gives us confidence that our model is forecasting things into the future. We rely a lot on our weather forecast partners to look at forecasted precipitation and temperature, so there's definitely some uncertainty there, but for the most part we do pretty good with our forecasts. When we talk about water supply forecasting, we're generally looking at least 3 months into the future, if not longer. And we rely on a lot of historical information. And I'll talk a little bit about the drawbacks there. But currently we're relying on the 1981 through 2010 period. So we come up with this huge ensemble, I shouldn't say huge, 30 trace ensemble of projected stream flows. And from there we can develop statistics. We can let people know what they might expect going forward. The Bureau of Reclamation is one of our #1 stakeholders, and part of that reason is that we're written into law that they have to use our forecast. I think we could forecast apples going downstream and they'd still have to figure out how to convert the apples to water supply into Lake Powell. But it's written into law, so our forecasts really just drive the decisions that the Bureau of Reclamation is making. So our forecasts go into their own reservoir operations model, and they're looking at those elevations at Lake Powell, Lake Mead, a lot of the other smaller reservoirs upstream to make those decisions. So I think over the next year, maybe 2 years down the road, you're probably going to start seeing in the news a lot about the shortage that may be happening in Nevada and Arizona, and further restrictions to California. It's our forecast that's really driving this hydrologic model, this reservoir operations model that is making those decisions. So again, check out our website. We do a lot to reach our stakeholders through our website. I'm just going to kind of highlight some of our more popular products. It's definitely just kind of scratching the surface of what we do, but I thought I'd show you a little bit of what we do. We do 10-day forecasts at over 400 stations throughout the Colorado Basin River Forecast Center. You can go right to our homepage and kind of get a quick outlook of what's going on in the basin. You can see where rises might be happening, where there are areas of hydrologic activity. And we do forecasts of 10 days out, so we're definitely trying to keep watch on any storms that are coming through, any potential flooding situations or recession limbs. People use these forecasts a lot for meeting environmental flow targets for endangered fish, that kind of thing. Again, working with the Weather Forecast Office, this is our last big kind of flood that came through with some hurricane remnants, and this happened down in southern Arizona along the Agua Fria. But we did have a quick spike above flood stage, and we actually went to 24-hour operations at that point to work with our weather forecast offices and the emergency managers to make sure they knew when we thought they were in the clear. Our water supply forecast is probably our most popular product, and like I mentioned before, we utilize this ensemble of 30 traces. We're in the process of updating that to 35 traces. But it's heavily dependent on precipitation information that we get. Our forecast, we usually start issuing our forecast in January, and our skill is kind of so-so. But as the snowpack accumulates, as we get more information, our skill continually gets better. And usually by April, we've got a really good handle on what the water supply situation's going to be. We do model soil moisture in our office. It's also a really important part of our model, but really the more information we have, the better. We talk constantly with folks on the ground to see and hear what they're seeing. We utilize remotely sensed data from NASA, their Jet Propulsion Laboratory, to look at things like dust on snow, to look at just snow cover in general. We're really trying to utilize a lot of these different types of information. This is just a plot of what you would see if you're looking at our ensemble forecast. And what we try and do is we try and show that whole range of information that you see. We actually make a forecast every day. We do an official forecast at the beginning of the month that you'll see there in red. But we're really trying to convey some of that uncertainty that you see throughout the water year and get that information across. We also do peak flow forecasts. Again, this is for folks that are really concerned about environmental flows, meeting environmental targets, whether that be for sediment or endangered fish. We really try and forecast what we think that peak flow is going to be. We don't really try and forecast the timing of it. Once we start getting to that part where we think, we think the peak's about to happen, we typically refer people to that 10-day forecast at the front page. So like I mentioned, we're really a stakeholder-driven office. We're really responsive to what our stakeholder needs are. So we do a lot of coordination efforts. The past 2 days, we've just held our annual stakeholder open house, and we had people from all over the basin come and see some of the new products that we're doing, some of the advancements that we've been working on. It's really a good opportunity for us to connect with our stakeholders and talk with them about what their needs are, how their needs might be changing, and for us to get feedback on what we're doing right, and sometimes a bit more importantly, what we're not doing right and what we can do better. We also have frequent webinars. If you're interested, get on our email list. You can just go to our website. There's a link that says email or something like that. And you can get on our email list. We'll let you know when our water supply webinars are. We can do custom webinars for your group. Say you've got a group that's particularly interested in the North Fork of the Gunnison River. We can give that group a custom tailored webinar that just talks about the Gunnison River Basin and those kinds of impacts. We also participate with a lot of our stakeholder meetings. We travel a lot to meetings like this, but also to meetings run by the Bureau of Reclamation or the USGS to give our perspective of things, what's working great for us, what we can do to help them. We write letters sometimes for the USGS. Some of these gauges get threatened due to lack of funding. Some of those gauges are really important to us, so we do our best to try and keep those things going. And there's a lot of like these landscape level kind of cooperatives that we've been working with as well too. So we've got challenges ahead, and we know that the climate is changing. Climate change is not something we duck away from in our office. It's something we accept. It's definitely happening. We know the temperatures are rising. I saw John Overpeck was on the agenda, and hopefully he talked about this temperature-driven drought that we're in. But it's definitely occurring, and we are seeing impacts from it. And even though the precip outlook is a bit uncertain, we do know that we're likely to see a decrease in our water supply going forward, especially for the Southwest and the Colorado River Basin. And our stakeholder needs are changing as well as our climate. Where we were in the past, people wanted to know, what is the forecast? What is that one number that I can base my decisions on? How much water do I have? I don't care, what you think the uncertainty is. I just want to know how much water there is. How much snow is there? Will there be flooding? Yes or no? But where we're really going now is people want to know what the range of forecast is. Like I showed on our water supply graphics, we're really trying to convey what that range of our forecast is, what the probability is, let people understand what their risk is to their operations. What is the likelihood of reaching a particular flow? What if I have one more dry year, 2 more dry years? What if this drought continues to persist? What if I get a really wet year next year? I'm really trying to hold on to as much water as I can in my reservoir. What's the risk I have of spilling? And they want to know what our uncertainty is. Where do we think errors are occurring in our model, and where do we think we can improve? So there's way too much text on this slide, but the big thing to take away is that we really are facing 3 big challenges. It's climate change, it's to our infrastructure and our modeling framework that we have, and really to outreach too. I think sometimes we get into this rut where we're talking to the same people over and over again. We really need to start talking to the decision makers that are on the ground. We need to start reaching out to people that may not have ever used a river forecast center. Maybe they rely on the Farmer's Almanac to do their planning. We really need to start doing our outreach to a more diverse and broad range of stakeholders. So as far as addressing the climate change issue, like I mentioned before, we really rely on past information to predict the future. But with climate change, this notion that stationarity is dead is a real one. We can't really rely on the past to accurately predict the future as much. It's not that there's no information in the past, but we definitely need to start looking at ways to incorporate some more climate information into our forecast. So one thing we're looking at is the University of Colorado developed a stochastic weather generator that can allow us to develop new futures, new weather combinations, new weather scenarios. And so we did a little bit of work on that. We had a student come in over the summer and kind of look at things. And don't pay attention to these numbers here because something's a little bit off right now. But what we were able to find is that we could generate a lot more ensembles, a lot more traces going forward. And this is something that we could start using, for instance, weights from the El Nino cycle or weighted things from the Climate Prediction Center. We can start using weights to start informing our climate and our stream flow projections a little bit more going forward. This, I think, is a really cool thing that I don't think we're stressing enough in our office, incorporating remotely sensed snow information. We have a model that was developed back in the 1970s. People weren't really thinking about remote sensing information. Modelers weren't thinking that this kind of information would be widely available or easily accessible. And what we're starting to do is we are actually starting to use remotely sensed information, looking at dust on snow, especially around the Gunnison River Basin, the San Juan River Basin, where these dust impacts are really significant. And what we're doing is we're tweaking our temperatures to adjust melt rates. So we're not, our model doesn't know anything about long wave radiation. It doesn't know anything about remotely sensed information. But what we can do is we can do some pre-processing and adjust what the model does look at, which is temperature, and get our melt rates a little bit better. So here's just a cool example here. This is no dust on snow information. You can see the observed data here in black. And you can see we weren't really capturing this early melt that was due to a dust event, accelerating the melt rate. And we're kind of over-predicting things just a little bit going forward. Incorporating the dust on snow information, we were able to capture that peak much, 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 much better, and even that following peak just down the road. So again, I was talking to Craig, who did a lot of this work. Okay, awesome. That I think it's really cool that we were able to take this really old model and use really new information and come up with something slick. So there's lots of different perspectives going on in the Colorado River. People think it's really dry and it's doom and gloom, and people think, we're not so bad. And it really depends on where you are and where you're trying to be, which kind of talks more to reaching out to stakeholders. And this is really cool, so keep your eyes out for this. It's not available yet, but it's really close. But this is our water resources monitoring and outlook page. It's going to be west-wide. It's not just going to be over our area, the Colorado River Basin, but it's going to be west-wide. Our forecast period is kind of lodged into the April through July period, but this is going to give you the opportunity to look at whatever period you're interested in looking at. You're going to be able to look at a wider range of area. You're going to be able to download a whole lot of information. It's going to be really slick, but yeah, this is going to be a really cool website. Keep your eyes peeled for that. Has anybody here heard of the National Water Center and the National Water Model? Oh, good. So there's been a lot of press releases basically saying that this new water model is going to solve all our problems. We can forecast a point anywhere. It's not quite there yet. It's really cool in that we have this really great supercomputer out in Tuscaloosa, Alabama, that we can run this large national model. But as far as operations go, it's not really there. Just these fancy graphics are just to show that these green lines are the national water model projections, and you can see they're way off from what reality is. I think they show the Jordan River putting Salt Lake City under 100 feet of water or something like that. But so you know, I think it's, you know, a good 5-10 years away, but you know, the technology is there and it's going to get better, but right now it's not having a huge impact. So if you see in the news that all the river forecast centers are using this and it's the best thing since our 1970s hydrologic model, it's not quite there yet, but it's cool. So just moving forward, Cadillac Desert is one of my favorite hydrology books out there, but I think if we want to live and thrive in a Cadillac Desert, we kind of need to learn to carpool. This notion, I was at this dinner with some folks, and the guy was just on and on about, you know, California's stealing all our water. If just California would stop, we'd be in great shape. As we're eating this salad in the middle of winter. And odds are that salad, that salad probably came from the Imperial Irrigation District or maybe down south in Arizona. So, you know, unless you're prepared to live really, really hyper local, we're all kind of using the water. It might get charged to California, it might get charged to Arizona, it might get charged to Utah, but we're all using the water. And we really need to figure out ways to work closer together and think of ourselves more as one basin, one community. So new partnerships, new voices, that's what we're really after here. And I think, pretty sure that's my last slide. So any questions? Yep.
What's different about the national water model, and why is it not working?
So there's a few reasons. So the big difference with the national water model is that it's really trying to model the entire country. We have the benefit of being able to calibrate our model to very local impacts. We have the ability to add very small diversions. We have the ability to talk with the Bureau of Reclamation, find out what they're doing with their reservoirs and that sort of thing. The National Water Model, while it's calibrated, it's trying to capture the entire country right now. And they're missing lots of diversion information. They don't have that close connection to the stakeholders to say, oh, how are you operating the reservoir? One of the reasons they're way over forecasting the Jordan River is that they don't know what Utah Lake is doing. And so they're just assuming lots of water is coming through that system when a lot of it's being held back in Utah Lake and even upstream of Utah Lake. So it's mostly just a lack of some of that local information and trying to calibrate over a huge area. But it's getting better. It's baby steps. Good question. Cool. Yep.
How do you account for all the diversions?
You know, it's really a lot of talking with the people that are operating those diversions. We get Oh gosh, we get so much data that's either FTP'd to us, or we have a lot of programs that go and scrape the web for data. A lot of these people are posting their diversions. Luckily in the Colorado River Basin, a lot of folks are mandated to post their information, post their operations. So we're just constantly scouring the web, and we get phone calls from people, we get emails from people. It's just a lot of data collection, and that's how we account for it all.
I think we have lots of experience of communicating with the stakeholders.
Mm-hmm.
If there are some cases, then the stakeholders come here and ask for information, but actually they don't understand it, or they understand it, but they don't believe it, or don't act to respond to this information.
Yeah, and that doesn't happen. I think it's getting a lot better in the Colorado River Basin. It doesn't happen too often. When it does happen, though, I think what we rely on is, you know, a lot of these smaller folks that may not want to use our information or may not need to use our information. They're going to get leaned on pretty heavily by the state agencies, by the larger agricultural users, because sometimes those little small operations can disrupt the bigger state and municipal operations. So you get a lot of like smaller users that get leaned on pretty hard by larger users. And so usually if we can relate and communicate with those larger users, it kind of trickles down a bit. So that's kind of what we rely on when we don't have a good relationship or a good response. Well, if anybody has any other questions, please feel free to contact us. We're really accessible. My email address is just paul.miller@noaa.gov. Yeah, feel free to get a hold of us. Thanks.